Let's take a look at how do we solve some of the more difficult questions involving a pair of equations. So let's say we are given a question like this. For which values of k will the following pair of equations have infinitely many solutions? Now, so we have a pair of linear equations. Now we know that we know that each linear equation represents a straight line. So now we have two lines. We know that when we are dealing with two lines, we can have the following three situations. So we can have our line 1 like this, and our line 2 can go like this, meaning these two lines can intersect. Or we can have a situation where our line 1 is like this, and our line 2 goes like this, meaning in this situation, both lines are parallel. Is there a third situation? Actually, there is. So let's say the third situation is something like this. This is a line 1, and now let's change the color a little bit, and you will understand why I'm changing the color. Now our second line is basically, it goes like this. In other words, second line and first line, they coincide. So now in the first situation, how many solutions do we have? We have only one solution. Both lines, they intersect at one point. How many solutions do we have for the second situation? 0, because these lines never intersect. What about the third situation? We have infinitely many solutions. So here in this case, we are dealing with the third situation. We have also learned that by simply comparing the ratios of the coefficients of x, y, and the constant, we can find out, are we dealing with the situation 1 or 2 or 3. So what we do is we find out the ratio. Let's write that very quickly. So if we have a1 by a2, we first find out this. Then we find out b1 by b2. So in the first situation, these two ratios, they are not equal. Then we are dealing with this. Now in this case, what we have is we have a1 by a2 is actually equal to b1 by b2, but not equal to c1 by c2. So then we are dealing with this situation. So this is this, this is this. And in the last case, all these ratios are identical. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. When we have this, then that means we're dealing with the third situation. Both lines are identical. So in this case, we are dealing with the third situation. That means our ratios should be all equal. So here a1 is k. So let's write it over here. So k by 8, a1 by a2 is equal to b1 2 by k. So this is our first ratio. So we have written a1 by a2 equals b1 by b2. Also, we know that b1 by b2 is equal to c1 by c2, right? So that means 2 by k should also be equal to minus k plus 6 divided by minus k. This is c1 by c2. So we have these two situations happening. So if we solve this, we will get k squared, simply cross multiply, k squared equals 16, or k equals, remember it is plus 4 and minus 4. It is just not 4, there are two values, plus 4 and minus 4. So this is what we get when we solve this equation. Now what about this equation over here? So here the minus minus will cancel out, and then we cross multiply here. So we will get 2k, which is 2k, equals k squared plus 6k. And we can bring the 2k over here. So we will get k squared plus 6k minus 2k is 4k equals 0. And from here, if we take k common, we'll get k plus k times k plus 4 equals 0. So when product of two numbers is 0, so this number can be 0, that means k can be 0, or this can be 0, which is k plus 4 can be 0, which when we solve this, we get k equals minus 4. In other words, if we solve the first ratio, we get k equals plus 4 and minus 4. If we solve the second ratio, we get k equals 0 or minus 4. So k equals minus 4 is the common value, and that is our answer. So for which value will the following pair have infinitely many solutions? For k equals minus 4, these two lines will have infinitely many solutions.